I've never really been into metal. I've always been a bit more pop, maybe some R&B, but I'm going to make an exception for this episode where I'm going to be talking about metal and metallic bonding for your A-level chemistry exam. Now, I don't want this to last long because I don't like metal. So we're going to do this one nice and quick, and it's going to be a concise review of metallic bonding. Now, key parts of metallic bonding are the fact there is a sea of free electrons. In a metal, the valence electrons delocalize and can move about the entire metal. This is referred to as a sea of free electrons. Metallic bonding is viewed as a sea of free electrons surrounding positive ion cores. The positive ion cores are attracted to the free electrons. You can think of the free electrons as like a cute little glue that holds the positive ion cores together. If you're wondering why those ions are positive, it's because remember, the metal loses its valence electrons. And because we lose those valence electrons, the metal becomes a positive ion. So it's often it's positive ions with a sea of delocalized electrons. Now, metals are good electrical conductors because the free electrons can move and carry a current. A general term for the moving particles which carry current is charge carriers. Makes sense. The melting point of metals is related to its group. A group 2 metal will donate 2 electrons to the sea of free electrons. This means the positive ion cores carry a 2+ charge. The 2+ ion has a stronger attraction to the free electron. This means the melting point is higher. This is really well illustrated by looking at sodium and magnesium. Now, sodium's in group 1, so the positive ion cores will have a 1+ charge. Sodium melts at 98 degrees Celsius. So that's about the same temperature that water boils. Mg, however, so magnesium, that's going to melt at 650 degrees Celsius. That's a lot. That's a big difference. So that extra charge, honey, it makes a difference. So 2 things about metallic bondings. A lattice of positive ions. So those positive ion cores form a lattice, and we have that sea of free electrons. And the properties you need to remember, metals are good electrical conductors. The free electrons act as a glue to bind the positive ions, and the more electrons that delocalize, the higher the melting point. Think about that example of sodium and magnesium. Sodium 98, magnesium 650. And that's just with the difference of 1 extra electron, because it's Na plus and Mg2 plus, so that's a lot. But to be honest, that's kind of everything you need to know about metallic bonding. It's not a lot. Just remember the positive ion cores, they form a lattice, and the valence electrons delocalize and form a sea of electrons, and they are the glue which holds the structure together. Fantastic. Hope this has been a useful episode. Thank you for joining me. I'm Jono from Seneca, and good luck with all of your work, and check out the other episodes. Make sure you're up to speed on ionic and dative covalent bonding too. You don't want to miss out. It's a riot. Catch you on the next episode.